Okay, good afternoon and welcome to the final session of this conference. It's a pleasure to welcome Achim Zeileis. I think we met at the DSC conference in 2001 in Vienna, and if you want to know a little bit more about his work, which is not just statistical, a lot of it is statistical, then some of it is being presented today, which is about how do you manage teaching stuff to unreasonable numbers of students who get thrown at you by your faculty, but also engagement in organizing meetings and conferences, so that of the people who've organized meetings and conferences for the R community, then probably you've been involved in not necessarily most, but a good deal, and you're also a member of the conference committee. So that if you want thinking of setting up a conference later on, then you know who to go to after the talk. But for now, we're going to be referring to a tweet which you sent out earlier today, which gives you the links to all of the information you'll need to participate actively in this. It's not a talk, it's
also a talk. It's also a talk.
It's also a talk.
Yes.
Okay, good. Thank you.
Thank you very much, Roger, and thanks to the organizers for inviting me for this wonderful meeting, and of course to all of you for making it such an exciting event to be at. So in this tweet, I have the links to my slides. So for those in the back rows who can't properly read everything, it might be easier to download the slides onto your smartphone or your laptop. And the second link here is a live quiz that I will be using to kick off my presentation in a moment. So I'll be presenting this package that we've been working on over the past few years, called Exams, and it's a framework for generating from the same pool of exercises exams that I can use in online tests, in small or in large groups, for written exams, especially for large groups, possibly also for smaller groups, that can be automatically scanned and evaluated. And all of this is based on a dynamic set of exercises that can be shuffled, random numbers can be inserted, and well, the same set of exercises can be used to render it into online tests, written exams, or a live quiz that you can use in your lecture to participate, make the students participate a little bit more than they would otherwise. And so this is what I'm using to start this. I'll put this QR code on for a moment. Otherwise, the link to this quiz is also in the tweet. So this is an audience response system, an open source system we are leveraging, so we can use our dynamic exercise pools to import questions into this question pool. So if you want to have one mildly amusing question about R-related conferences and two examples for the kind of questions we ask our students, try to get into the quiz. And I'm showing you the questions here. So I'll present the questions first. So this is the mildly amusing question: which of these institutions already hosted a Use R or eRum conference? And it's mostly static questions with a static set of answers. That's just shuffled a little bit. I'll show you in a moment how we do that. And then we also have a second question that we use in our math course, an introductory math course for business and economics students. So we repeat how to compute derivatives and optimize functions. So this is a typical example we might use during a lecture to see whether people are following along, and a simple thing they can they can compute and see whether they got it right. And then there's this function. You're giving a system of linear equations in a slightly different way, and are then asked about computing a certain equation with it. So we already have a few answers. So the first one is probably the one where we want to see the results now. The other ones are not so exciting, and you would all be able to solve these exercises, of course. So let's see this. I make this a little bit more readable. So which of these institutions already hosted the UseR or eRum? We have Universität Wien, ETH Zurich, Copenhagen, Poznan, and the Agro campus in Rennes. And so we have a clear favorite. So the eRum participants remember that the previous eRum was in Poznan, and but then we get a quite diverse picture. So there was never a conference at Universität Wien. There was one at Technische Universität Wien and at Wirtschaftsuniversität Wien, but not at Universität Wien. So trick question, but was a little bit unfair. ETH never hosted a big one. And Copenhagen hosted DSC conferences, but not UseR. And well, we had UseR 2008 in Rennes. So this is something like this I try to do with my students as well. So to show them a few things where they can see, well, I'm already following, and maybe put in also a few aspects that they didn't know yet. And I might use this as a live quiz, like I did now, or something that they can do in their own time. And well, I think I leave the quiz here at the moment, just because people have been using this already in this tool. You can also ask questions and provide feedback and use this. So this is a nice. Maybe I should switch again. So this is a nice thing for teaching. So this tool, Ars Nova, is something we use. We're not involved in the development of that, but we can import our exercises into this tool. So because we're teaching to large groups of students in parallel, we don't always have the same questions, but we can easily randomize. So I have already talked a little bit about our motivation. So the cohorts of students we typically phase both in Innsbruck and before at WU Wien were easily in excess of 1,000 students. In Innsbruck it has gone down a little bit now, but we had several lecturers teaching the courses in parallel. We had very large scale written exams and wanted to because these were introductory courses, the level with which the students came to us was rather different. So the math course is in the first semester, and some people come from a background where they already know most of the stuff that we would repeat for them quite well, and others have larger gaps, things they didn't learn in their type of high school. So we wanted to try to individualize the organization of the learning, feedback, and assessment process as much as possible, while assuring a certain quality standard, while having the same materials at the core of the course for all students, for all lecturers, to drive everyone towards the same goal. And in this matrix, I show you the learning, feedback, and assessment. And for all aspects of this, we have synchronous and asynchronous tools we're using. So synchronous typically means in the lecture room while I'm teaching or while we're doing the tutorial sessions or the written exam. And asynchronous means students can do this in their own time over an extended period. So we have, for the learning process, this is pretty standard. We have a textbook, we have our corresponding presentation slides, we're live streaming the lecture, and we also produce dedicated screencasts that students can view in their own time. But the other two columns is what I'm concerned with in my presentation today. So we wanted to have the same exercises available in a live quiz, like the one we just conducted, where additional feedback can then be given by the lecturer hosting the tutorial, and in a self-test that students can take in the learning management system the university is running, which is Moodle for many universities. We are using OLED, Swiss open source system. Blackboard, of course, is quite well known. Canvas is gaining momentum. There are various other things out there. Then students can do this themselves. And if we provide the solutions for the exercises along with the questions, they can have more feedback, or they can ask questions in the forum. And then we have the assessment, and we have a formative phase in the assessment over the course of the semester. We're using online tests that run for several days, so students can talk to each other, they can help each other, and this is all encouraged by us while they're doing these online tests. And then we have written exams. We could also try to have online exams, but our groups of students were too large for the rooms we have for that. So we need some scalability, we want to have feedback in there, and we want to have the flexibility to do all of these different things from the same pool of materials. And this is why we started writing our exams package. And in our package, every exercise is a standalone document, either RMW or RMD, it at least contains the question and some meta information, but might also contain the corresponding solution. And like any other RMD or RMW file, it can be made dynamic if R code is included for drawing numbers, for shuffling text blocks, for generating different kinds of graphics, and so on and so forth. And then there are different answer types that you can use with our package. The most popular ones are included, and single choice and multiple choice being the ones that are being supported by most of the systems that are out there. And then you can tie together an exam from these exercises and render it for printing, typically into PDF, or for online usage in HTML. And we have the possibility you can use your own template, either for PDF or HTML, or you can use a standardized solution that helps you with the evaluation afterwards. Whereas if you use something customizable, you're on your own if you want to evaluate the results later on. And I already mentioned a few of the systems we can render this into. And for doing all of this, we're standing on the shoulders of a lot of other open source solutions. Naturally R for the computing, and LaTeX and Markdown for the writing and reporting, Knitr, SWeave for the reproducible research kind of tools, and then all these document conversion tools, embedding images in HTML, uploading them into systems, and of course the learning management systems themselves. We also have interfaces to commercial solutions like Blackboard, but we have of course several we have a certain focus towards open source software there as well. Okay, so I'll try to take you step by step through this process. So the root of everything is a single exercise. What does this look like? And I already said we can have some data generation optionally, might not have that. We have a question, might have a solution, and then we need some meta information that the system knows what's going on. And I'm briefly showing you 2 examples. The first 2 questions from the quiz I showed you before. One is written in R Markdown, the other one is in R and LaTeX. So this institution question for the conferences is very simple, quite static question. And if I would have been only interested in running this with Ars Nova, I would have entered it in Ars Nova directly. I wouldn't have bothered with any outside system. But if I wanted to use the same question also in a Moodle quiz or in a written exam, then it is nice to have it abstracted like this. So this is a Markdown document. We have a question, and then we have a list of answers. And here I have 6 institutions listed in the quiz. I only showed 5 of these in a shuffled order. And then the solution looks very much the same. Ars Nova doesn't show the solutions, but in, for example, Moodle, I could have showed the solution if the student entered something or if the student entered a wrong answer. And then I can also include some explanations, which is pretty much what I told you here in this live situation, but which the student might need if he or she is doing it by herself at home. And these solutions are quite useful not only for the students, but also if you have a large group of lecturers, so that everybody knows in which way you should explain the solution, for example. And then there's a little bit of meta information. We have a name, we have a type of exercise, in this case M-choice, because it's a multiple choice question, and then the solution is binary coded. We had here 3 true and 3 false answers, and then we said X shuffle to 5, so we always draw a random selection of 5 from this. So the correct solution is actually inferred from this meta information, not from the explanation in the solution. So we here, you can't see this, these true, true, true and false, false, false statements with the explanations, these are not processed by the system other than rendering it into PDF or HTML. Okay, and then we have an S-weave exercise about the derivative. We had 3 parameters in there, 2 power parameters, and then the argument at which we want to evaluate the derivative. And well, then the exercise starts with a code chunk that randomly draws the 3 parameters from certain ranges, and then computes the result based on the correct formula that we computed by hand before. And then the question is now entered in LaTeX style. You have begin question, end question, and in the question you then use S expression to insert the parameters that you have sampled. And the limit with what you can do with this is really your imagination, as you all know. I mean, Markdown and R Markdown and Knitr and S-weave are incredibly flexible. You can insert graphics, text blocks, and you can even insert data files, for example. And the solution in principle works in the same way. It looks a little bit messy when displayed like this on the slides, but I guess many of you have written documents like this, so it's not so bad if you write that exercise yourself. And then again we have the meta information now entered in LaTeX style with \x type, \x solution, and so on. And the solution is of course a dynamic variable here as well. And maybe I quickly switch to my R session here and try to increase it a little bit further. And so what I can then do with these exercises inside R is I just say exams to HTML, for example, on my R&W exercise, for example, and then for a single exercise it fires this up in the browser, and then I get the question and the corresponding solution, and I can do the same again, and then I get a different question. Well, sorry, I get different numbers in the two exercises. And then I can do this multiple times, of course. And if I don't want HTML, but I want PDF, I can say exams to PDF, and then it uses a default template to generate a PDF, and I can then say, we'll see that later on, exams to NOPS, which generates a format like this, where you have then a field for entering the multiple choice marks. But we'll get to that in a moment. Okay, so we then have these different kinds of exercises. Single choice you have already seen. It's called S-choice. In our format, the solution is binary coded, false, true, false in this case, and you can use this type of exercise easily for knowledge quiz questions, like this one asking about the capital of Switzerland, or what the Swiss have as a sort of capital. And then you put in the correct solution and some shuffled distractors, or you could have something like this derivative exercise, that it's actually a numeric solution, but you put in some distractors as well, where the distractors might include typical arithmetic mistakes students might make. Then we have multiple choice questions, which we can again use for knowledge quiz questions, like the one you've just seen. And this type of exercise is also quite nice for interpretation questions. So you might display a graphic, you cannot read the text probably, but you can see it's two parallel box plots, and then we can ask, okay, is the location about the same or is it different? Which is of course quite easy to see, but then I might also ask, is the scale, the variance, similar or different? And things like that, to practice interpreting box plots or scatter plots or something like that. So we make several statements, each one of which can independently be approximately correct or clearly wrong. Then numeric exercises, of course, where the result is a number, like this example with a linear system of equations with some icon images in there, where the students have to enter a precise number. We might also want to take string questions. The tricky thing with the string questions is how to evaluate these. Exact matching is quite easy, and you could use this for a question like this: what's the name of the function? And then you can do exact matching. Some systems also support approximate matching, but that's quite system dependent, and we have little infrastructure for that on our end. And of course you might also say, well, I'm doing the marking by hand afterwards, so I might have a quiz conducted online, and then there are various things students can enter and immediately get the feedback, and some things I have to go through afterwards, and many systems support this. And finally, there's this closed type exercise, which combines these things. So you can have first a multiple choice or single choice question, then some numeric results, and then some string results. And this is something where you can do quite powerful stuff. So it's quite nice to use these kinds of exercises for tasks where you provide a data file that you can embed into the HTML. So here I'm sharing a CSV file, and then students are asked about either choice questions or have to compute something like compute the slope in a linear regression. And I can quickly show you what this looks like in HTML. So here you get the hyperlink, and if you click on this, then a dialog opens and lets me download the CSV file, and then I have to judge whether there is significant correlation, yes or no, or positive or negative, and I have to compute the slope. Okay, and then we have our exercises, and then we want to render them into different kinds of formats. So we support these various types of outputs, which generally fall into two types. There are formats where I produce one file per exam. For printing, for example, you can do that in PDF or HTML or Word documents or LibreOffice documents or what you want. Or you render them into one combined file containing the entire question pool for all exercises that then can be uploaded into a learning management system, for example. And the way how you define the exam is always the same. You set up a list, which is a list of file names. And here I'm setting up a list with 3 elements. The first exercise is always this derivative exercise. The second one is always the fruit exercise. And the third exercise is randomly drawn from 2 elements. It's either a t-test or a box plots exercise. And I wouldn't necessarily combine these two in the same exercise, but just to show you what in principle can be done. So what the package then does, it goes through the list, it draws by default 1 element from each list member, but you could also specify the first exercise element is 10 files, and I always want to draw 3 out of these. That's also possible. And then once you have selected the files, then you run knitr or sweave on the files to draw the random numbers, if any, and then you read everything into R and render it into different output formats. And yeah, then I have hinted at this already. There's exams to NOPS for this format with the standardized PDF exams, exams to Moodle, exams to Ars Nova, exams to something or other. So there are quite a few of these exams to functions. And this is what we'll get into next. And we'll start with the written exams here. You can roll your own if you want, using exams to PDF or exams to Pandoc if you want to go to Word documents. Or you can use this so-called NOPS format that we didn't come up with. We followed a standard used at our university, and this is intended for single and multiple choice questions, has limited support also for open-ended questions that have to be marked by a person before scanning it. But the main purpose is single and multiple choice questions. And so if I run this through exams to NOPS, you get the main exam sheet where students can use the top right to enter their student registration number, and then at the bottom there will be the fields where they can enter their answers. So the process how you would go through with this NOPS format is you would first call exams to NOPS and generate the desired number of exams. We use, if we have an exam with 1,000 students, I generate 1,000 different exams. And then you print these out. With 1,000 exams, we take them to our local print shop. For smaller exams, I print them out on my printer. Then I conduct the exam as usual, and for most exams I only collect the first page, let the students take home their individual exam, because they are different anyways. And then I go back to my printer, take the pile of paper and let them getting scanned. And the result of the scanning process I run through an R function, again called NOPScan, which transforms the PDF or PNG images, standardizes them to PNG, reads where the crosses are, and puts them into machine-readable format. And then there's a function called NOPSEval, which then assigns points, marks, and stuff like that. And then I get an HTML report for each student that I can upload into the learning management system that shows name and a table with a sort of traffic light system showing them what they solved correctly or partially correct or incorrect. And there's also the scan sheet included, so they can check whether the scanner made a mistake somewhere. Some cross was not read correctly. Okay, and then we want to do e-learning either in a smaller room together, or students can be anywhere on their own machine doing this in their own time. And yeah, I've mentioned this a couple of times. We want to leverage the system the university provides for this. What the R package does is it takes the set of R exercises, so RMD or RNW. For each of these generates random replications, and then combines all of these into an exchange format, often XML based with HTML embedded in there. And then I upload that into the system. And just to show you quickly what the result looks like, this is our learning management system, and I'll try to make this a little bit larger, but then it switches to responsive mode. Well, but you can see that I have again the same question here, and now I can enter a number and submit that, and then I can or cannot provide the feedback. So when generating the file for our OLAD system, I can say I want to include the solutions or I switch off the solutions. So in certain scenarios I give students the full solutions, and in some situations I do not. Okay, and well, there are some screenshots from Moodle, from OLAD, and from Ars Nova, and these are not very readable here anyway, so I skip over these. This gives you the functionality that's currently in the package, and I wanted to take the last few minutes to show you what we're currently working on, or ideas we have for extending the package, what we'll be doing next or have started doing. And well, we have a list here, but I go through most of the things one by one anyway. So one thing I've added after a while, after establishing this exams to NOPS function, it was first all in English, and then I added support for internationalization so that you can have these texts explaining how to mark the boxes on the exam sheet and where to put your name and stuff like that, so that this can be easily translated, and you cannot read it, but we have here this is English and French and Hungarian. And we already have a list of quite a few translations. Just an hour ago I received Polish. That's not yet on the list here. And more contributions are welcome. Simply send me an email, let me know if you want to do something in that direction, and then we can also bring it into the package. Then we have started developing this stress tester. So if you have a dynamic exercise, it's important to check that the random replications really work. And for the content of the exercise, there's no other way than someone looking at the program, looking at the output, and doing this thoroughly. But we can do some automated checking as well. So the stress tester runs an exercise a lot of times, by default 100 times, but you can also set this to 5,000 times, and then you see how long each replication took, what the distribution of the numeric solutions is, if there are numeric solutions, how the correct solution is distributed over the choices if you have a choice-based format, and what is the rank of the numeric solution in this choice-based format. So this is for this derivative exercise, and you see it's never the smallest or the second smallest answer, and that's because we have included two typical mistakes when computing the derivative, and both of them are systematically smaller than the correct solution. And then it's up to the lecturer to decide whether this is something he or she wants to go with or not. Sometimes this is an opportunity for students to do some text mining and game the system. Yes, it's amazing what students can do based on pattern recognition. I'm always amazed. I had examples where I wasn't aware that if there's a negation in item A, then it's false. And I was seeing that on the help forum. They were posting it to each other, and I was like, this cannot be true, but it was true. And then I fixed it. So it's quite amazing. And with mistakes like this, the question is always, is the mistake common enough that you still want to include it or not? And we have some cases where these really easy systematic mistakes are picked up quite often. What else are we doing? We're working on a Shiny interface that makes the system more accessible to people who are not using R or who are not using R as often as we are. But this is still heavily under development. You would have an editor. You cannot read anything of this anyway. And then you could get previews, and then you could click buttons to get the Moodle output, for example. And the last bit I wanted to show you here is something on examining exams. And this is something I'm doing with my exams, and I really want to wrap it up in some function that gives a report for the person running the exam. But yeah, I still didn't manage to put everything in place as I would want it to. So I'm showing you one exam analysis that I would run. So I'm interested in exercise difficulty, student performance, and unidimensionality/fairness of the items. And I'm using methods from psychometrics for this, specifically item response theory, and I'm looking at end-term results from our first-year math course. So they have been taking online tests over the course of the semester, and then at the end of the semester there's one written exam. And in this semester we had 941 registered students, and only 729 bothered to show up at the final exam. The others said, oh, it's hopeless anyway, I'm doing it again next semester. And we had 13 single choice questions like this derivative one. The derivative one is quite easy. We typically do not have that in the exam, but in the same spirit. And because there might have been up to 1,000, almost 1,000 people showing up, we needed to split the group into two, because the sports gym where we conduct the exams for our university can only accommodate up to around about 700. And so we had two groups, and because there was a short break in between, we used partially different exercises to avoid cheating. So the exercises were on the same topic, but might have had a slightly different function or a different story or something like that. And I have some short code snippets I'm showing here that give you a feeling for what's going on. If you want more code, it's in the PsychoTools package. So this data set and the examples are in the PsychoTools package. And on the left, I'm showing the raw proportions of questions not solved correctly. So the dark bars are not solved. So we had a few very simple exercises, one extremely hard one, a pay flow exercise where you need to solve an integral. And students don't like that, at least our students. And then some things in between. And then we estimated a formal IRT model that assigned an item difficulty to each of these exercises, and the pattern looks rather similar to what we had in the raw frequencies. And then we can combine this with student performance. So if you look at the points achieved, there's this vertical line showing the 50% mark bar that had to be crossed, and the students calibrated them to just make it over the bar. There are a few who study for a good mark, but not so many in our cohort, unfortunately. And from this, you can also align the student performance on the same scale as the item difficulty. And this is on the right. So we have the item difficulties and then the distribution of the estimated student abilities on this latent math scale. And you see that they have calibrated them right in the middle and with a sort of 50-50 chance of solving most of the items. And then we're concerned with unidimensionality, especially here because we had two groups. Were the questions fair? Were they equally easy or difficult between the two groups, or also between other groups, between males and females, native speakers against foreign language, fields of study, age, I don't know. Yeah? And here I'm just showing you the comparison of the two groups afterwards. So first I ran a simple principal component analysis to check whether this is really unidimensional, and I get one factor that explains a lot more variance than the other principal components, so that's good. So it looks like I'm on track for one math dimension. And we see that most of the biplot arrows point in one direction, but we have three exercises diverting a little bit from the rest. And if we then split our sample along the two groups and estimate two Rush models, we can also formally test whether these are significantly different. And we see some pairwise confidence intervals on the right, and the three exercises that showed up in the biplot also show up here as being significantly different. And on the left, for example, in the first exercise, this one here, you see the first exercise, which we intended to be very easy, was in fact quite hard in the second group. It was exactly the same calculation that the students had to make, the same structure, just a different story. Only the stories changed. And the surprising bit was, one story was in the exam in the previous semester, in the written exam, and the other story was in the online tests in the same semester. So you can now guess which one is which. Students had taken the online test with that exercise in October, and they forgot about it. But when they prepared for the exam, they looked at what the others did the semester before, so that one was a lot easier. And this is really hard to predict, but at least we found out. And we try to take care of mistakes like that not happening again. And nobody complained, nobody sued us, so. But I didn't show them this graphic, so. Okay, so to wrap up, a couple of recommendations if you want to try this yourself. What to do? Start simple, especially the ones coming from having their own exams in a LaTeX format. Don't worry about the formatting. things might look different than they looked up to now, and for the start, don't worry about this. Focus on the content first. Start with simple exercises, maybe start with static exercises, then make them dynamic, and then take it from there. Then include data, and this makes it easier to get accustomed to the system. Especially worry about formatting later on. Try not to do it alone. Try to do it together if you can. If you find people willing to do this with you, it's much more fun, and it helps you in quality control, and you can give each other feedback, find out typical mistakes, stuff like that. And my experience is you can be creative here. Try out things. If you do this in a feedback phase or in a formative assessment phase, students are quite forgiving. They see that you make an effort, you're trying out new stuff, and they will appreciate that. At least that's my experience. In the summative assessment, maybe don't be too adventurous to start with, because this is what drives the mark a lot, and students might appreciate some more security there. And especially for the summative assessments, in our case written exams, a thorough quality control is very useful to avoid problems later on. But what we do, for example, is we let the students help us with it. If we put a new exercise first in an online test and we made a mistake, we can just say, okay, sorry, we screwed up. You all get the point for this one exercise, and nobody is angry with us. But then we had a couple of hundred students trying out this exercise, and this happened fortunately very rarely, and otherwise, if it all went through smoothly, you did a good deal of testing, and have probably not a problem with that exercise. Okay, and on the last slide there are just some links. We have a support forum. We have a tag on Stack Overflow. I'm on Twitter. If you want to ask something, get in touch. And if you have something interested to tell, successful, unsuccessful case studies, I would be interested to know about this as well. Thank you very much.
So there's time for a couple of questions. Do I see any hands? There's one there. You second. There's one before.
Thank you for the I would like to ask if you would like to incorporate some allowance for preciseness in the numeric answers, mostly for not calculation mistakes but rounding errors.
I'm not sure I got the question right. So you for the numerical solutions, you want to assess how precise they were?
No, but allow students to make roundings and still be right.
Okay. So in the process of solving the exercise, to let them do a certain amount of rounding mistakes and try to assess that. You can try to do so, but this is something that you then have to program into it. We have no dedicated infrastructure, because in general that's quite hard to know where this goes in and not. So what we do in our online tests is that we give students 2 attempts to solve it. If they didn't get it correct the first time, they have another shot. And in the written exams, we only have the single choice format, and we make sure things are sufficiently different. But we don't have anything systematic where we could say, oh, it looks like you made a rounding mistake, go back to the beginning. So this is something we do by hand in the support forum, for example.
So, thanks for the talk. I loved it, and I'm very impressed by your work here. I have 3 questions. You can choose whichever you want to answer. The first one is right-to-left languages. So Hebrew, Arabic, how well is it supported? How well could it be supported in the future? That's the first. The second one is, you didn't mention MathML, but if the only reason we're doing LaTeX is just for the math, could we just work with that? And the third one is, I imagine you considered, but I'm wondering what your opinion is about having a database of questions for somehow validated teachers, because obviously you can't have it online, but to have it in somewhere. I'm sure you thought about all of them, so...
All excellent questions. And so the first one, the language, is in principle we have encoding support, and so we have seen, as usual with encodings, seen people struggling with it, but also succeeding with it. So far, this was for relatively simple languages. If you would try to write a NOPS translation in Hebrew, I would love to have that, and it might turn up some problems with my code, and then I will extend it. I think it should, in principle, work out of the box with UTF-8, but at least I tried that it should work out of the box. The second point was about MathML. Thank you. So when rendering to HTML, we support a couple of things. We either go from Tech to MathML. That's the default that we started with, because back then when we started, Pandoc wasn't as mature as it is today. But you can now also use Pandoc to go from Tech to either HTML with MathML or HTML with MathJack. So you can do everything that Pandoc does, and it depends on your learning management system what you want to do. And if you start out from Markdown, you're using Pandoc anyway, so you can do what Pandoc can do. And it depends on the back end, on the front end, what you want. So some systems support MathJacks, others don't, and the third question was about collaboration. I think there's potential for this. We're at the moment sharing our exercises with those who ask us. So if anyone's interested in German mathematics exercises for business and economics students, let me know. But we haven't put them up because there's both copyright issues, if student assistants help with that. So I didn't go through with university asking who really owns the IP for that. So far, nobody asked, and the other thing is, of course, some people are concerned that students might learn from this. Depending on how complex the question is and what you use it for, you might actually not mind. And there are some people who are sharing exercises like this, and if something like this develops, so if anybody starts saying, oh, I'm opening a repository here and come to my GitHub project and contribute, I think that would be fantastic. We haven't done so for the reasons I named, but I think this would be a cool thing.
Okay, so then we'll move on to the next speaker. Thank you very much, Achim.